Okay, good morning, e-learners. No questions at all? Crying is allowed, but do it softly.
Me? What? You started it.
That is true. I mean, he's not wrong.
I gotta back myself up.
All right, let's grade this sucker.
That's not my fault. But it is. Sorry.
All right, here we go. 1 through 6 all.
No, I swear I thought it was.
Okay, so your goal was simply to look at the angles and tell me the relationship. And remember, we have, I don't know, 6 or 7 of these. We got exterior, interior, alternate interior. We got same side interior. We got corresponding. Those are the basic ones they wanted you to use. All right, number 1, 2 and 6 are alternate interior. Number 2, 8 and 6 are corresponding. Number 3, 2 and 3 are same side interior. Number 4, 3 and 7 are alternate interior. Number 5, 5 and 7 are corresponding. Number 6, 3 and 1 are corresponding. Am I going too fast? Okay. Then we had 12 through 17. It's the same idea. Now, they go from this 1 through 6, this nice, friendly drawing. I will show you a friendly drawing today as well, too, until the very end. The very end is a bit more challenging. But they will go from this nice, friendly drawing to this Mongasso. There's lines going every which way. It's hard to see.
Who is
I don't even know where that word comes from. My suggestion, when you get one of these weird ones, right, if you need to draw an alternate drawing, instead of having all the lines, just draw the 2 that they are talking about. This one's involving the third because there's a transversal. So sometimes just redrawing the shape, I believe this one looks more like this, right? And it's got another line that goes from here to here. It's really messed up. All right, so here we go. Number 12, those 2 angles are corresponding. Number 13, those 2 angles are corresponding. Number 14, those 2 angles are alternate interior. Number 15, same side interior. Number 16, same side interior. Number 17, corresponding. And then 23 through 28. All right, 23. This is the hard one because it's saying refer to this hexagonal prism, which we don't even know the name of that yet, but we know it from pre-algebra, right? That it's a hexagon and it's a prism because the sides are rectangles. But in geometry so far, we don't even know what a hexagon is. We don't even know what a rectangle is. I'll just say the hardest ones in these books are the 3-dimensional ones. And so you have to be able to look at the shape, right, and be able to interpret it in 3 dimensions, even though it's drawn in 2 dimensions. All right, enough talking. So it says, name 5 lines that appear to be parallel to AG. AG is on the left side, and it's a vertical line. So any other line that would be vertical around the hexagon would be parallel to it. So that's line BH, CI, DJ, EK, and FL. Now, if you wrote yours backwards, instead of EK, you wrote KE, that's the same sign. All right, number 24, 3 lines that are parallel to AB. AB is one of the sides of the top hexagon. So the only other lines that would be parallel to it, it's a hexagon. So hexagon, you're over here, then this one will be parallel, this one will be parallel, and this one would be parallel to it. The e-learners can't see what I was doing right there. So those parallel lines would be GH, ED, and KJ. And once again, if you wrote JK instead of KJ, it's the same thing. 4 lines lines appear skew to AB. There's lots of them. There's lots of them. I will check that one myself. All right, planes parallel to AF. AF, parallel to AF. So that means they have to go through AF or be parallel to AF. Well, obviously, I'm sorry, did I say AF? Yeah, it is AF. So any of these 3 letters, C, D, J, or I, any combination of those, or the combination of G, H, I, J, K, L. Pick any 3 letters of what I just called out. That would be the name of a plane. All right, FL has lots of them, lots of them, lots of them. ABHG, or any combination of the three of those, BCIH, any combination of those, CDJI, any combination of those, and DEKJ. Now, why such weird? Because the first ones are talking about ones that are parallel to, they could be parallel to the top or the bottom. And since it's a hexagon, it's got it's got 6 letters. That's why so many. All right, 28. How many pairs of parallel planes are shown? Okay, this is hard. This is hard. So it's a hexagon, right? So it's obviously top and bottom. Well, let me grab my hexagon. Grab me my hexagonal prism. Yeah, thank you. So you learners can't see this. I got a hexagonal prism in my hand. So top and bottom are clearly parallel. There's 1. Front and back, there's 2. This side, there's 3. And this side, there's 4. So it ends up being 4 sets of parallel planes. You're like, wait a minute, what about the one that goes straight down the middle? Now, they're talking about ones that would include the sides, top and bottom, right? If you include that you can go through the middle, then there's an infinite number of parallel planes. And that was 28, and then 30 through 39. All right, I'm going to call these off quickly. I'm just going to tell you straight up. There are 4 of these on the test. Sometimes, always, never. Sometimes, always, never. Sometimes, always, never. All right, number 30 is always. Number 31 is sometimes. Number 32 is never. Number 33 is always. Number 34 is sometimes. Number 35 is sometimes. Number 36 is sometimes. Number 37 is always. Number 38 is sometimes. And the last one is sometimes. These are hard. These are as bad as true false, right? Typically, they're trying to trick you in some form or fashion. But sometimes, always, never.
50%. That's 1/3.
What?
You have 1/3 of a chance to get it correct.
I agree.
If I guess.
33%.
Right. If you're guessing.
If you're
Oh,
guessing,
hopefully, you're not guessing.
fingers crossed.
All right, Seth, go grab the next handout from the basket and collect the whole for me, please. Can you do both things at once? Good job knowing what a hexagonal prism is. All right.
Caleb must be smart. No.
Let's see. We have a quiz on Wednesday. We'll talk about it tomorrow. This is a pretty short chapter. Notice there's only 6 sections. We may take a pause depending upon how we think we're doing. All right, and I will be the judge of how we think we're doing. We might take a pause, meaning we might have a review day midway, somewhere around the quiz, Thursday, Friday-ish. If I think we need to look at the material a bit more deeper, or I should say with more practice. If not, then the next chapter test is on Tuesday. All right, here's your homework. Uh-oh, not much. That must mean it's challenging.
No.
It's geometry. It will be torture. Geometry is challenging. I personally think it's for most kids, it is the hardest math that you'll do in high school because it's logic. There's only a few things that we'll do where there's a procedure. Hey, follow these 3 steps, get to the answer. Most questions in geometry require you to think it through. And that's why I like it. Geometry is the only one that only thing I ever teach that a kid will ask a question and I will I don't know the answer to that. I gotta think about it. Algebra 2, pre-calculus, calculus, I mean, I know the answer. Hey, just do this. I might make a mistake, but there's little thinking involved. Geometry is nothing but thinking. Geometry is also one of the few times where kids will turn in work and I will not know if it's right or wrong. I will have to actually do some thinking about it. Wait, could it be done that way? Oh, wow, it actually could. Today we will do the first proof that I expect you to be able to do. It'll be the first time that I literally say, you should be able to do this proof. One of them. We'll do 2 proofs today. The second one, no. But the first one, you should be able to do the proof with no hints.
No.
All right. Here we go. Oh, such a nice, friendly title. Properties of parallel lines. This is the start of geometry right here for me. This is, for me, is where the book really starts. It's also doesn't get any more harder than today. Like, we don't have, like in Algebra 1, I'm like, well, you know, some of Algebra 1 is simple, but some of it's really hard. Geometry stays the same almost the entire year. So most classes are just like today. All right, so we're going to have a couple theorems and a postulate. So yeah, the rest of geometry will be exactly like today. Last class, we talked about this construction. This construction was 2 lines cut by a third. We say this third line is line T. We call it a transversal. And we got a whole bunch of angles. Chandler, give me one type of angle you get from this construction. Those names that you wrote down on Friday. Give me one of them. I haven't counted, but I want to say there's 6 or 7 of these. Give me one of them.
Alternate interior.
Alternate interior. All right, he names it. Wes, you give me the alternate interiors.
5 and 4.
5 and 4 alternate interior. Excellent job, both of you. All right, you give me a name, and Cadence, you got to name the angle. He said alternate interior. You can't use that one again. Give me another one.
Corresponding.
Corresponding. Give me some corresponding ones on this shape. What 3 and 7 are corresponding. Same side, same position. Hey, we're kicking butt so far. All right, Madison, you give me a name, and Liam, you give me the angle. Same side, exterior, Liam.
2 and 8.
Are we going to get any of these wrong? All right, you name the angle. So we had alternate interior, we had corresponding, same side, exterior.
Alternate exterior.
Alternate exterior.
1 and 8.
I was expecting us to have problems. So far, we've had no problems. We only have a few left. You name it, and Seth, you name the angle.
Right.
We already said alternate interior.
We have not.
What did you say?
Yes, no, we have. Alternate interior, wasn't that Chandler's?
Yeah.
All right, yeah, we have had alternate interior.
Same side interior.
Same side interior.
4 and 6, 3 and 5.
Do we need to do more of these?
No.
All right, you guys are kicking butt. These are all the ones that I gave you on Friday, right? We left off just the interior, exterior. I'll just say this. We don't really, except for maybe the test, I might say name the exterior angles, but we're not going to get any theorems or postulates from just interior or just exterior, right? From here down are the ones. So 1, 2, 3, 4, 5. Those are the big 5. Alternate interior, alternate exterior, same side interior, same side exterior, and corresponding. For the rest of the chapter, we'll be dealing with those 5 right there. I mean, a whole chapter on this. All right, this class and many more, right? To include in the next chapter as well, too. Instead of doing this construction, we make one small change. What's the small change? Anybody already know? And this is what you learned in pre-algebra as well. The small change is instead of constructing it like this, we're going to do something special with H and K. Anybody know? We will make H and K. The lines can't be congruent. We will make them parallel to each other.
That's what
Right.
I thought, but
So we're going to make H and K parallel to each other. So this class and many more, this is the picture. Now they can take this and rotate it around, but 2 of the lines will be parallel cut by a third. So every postulate and theorem we get for the rest of the chapter deals with this shape right here. 2 parallel lines cut by transversal. All right. So you'll see something like, H is parallel to K, cut by T. So the first one we're going to get is the easiest one. It's a postulate. Remember, we don't prove postulates. Postulates are the duh. So in your book of truth, it's going to be postulate 10. No one's going to remember postulate 10. You're going to remember what it says. Here's what it says. If you have this construction where H is parallel to K, corresponding angles are congruent. So when you state this in the proof, and this one will be stated plenty of times this year, you're not going to say postulate 10 because, well, maybe you will. Most people will just say, hey, corresponding angles are congruent. And the abbreviation will be CORR, corresponding, angles, angle symbol, congruent, congruency symbol. because we are efficient in math. For those of you that like the statement in blue and statement in red are the hypothesis and conclusion. Two parallel lines are cut by a transversal, and corresponding angles are congruent. It's a postulate. We don't prove it. We accept this as true. So somebody's got to explain to me, why do we not have to prove this one? Why is this obviously true? Why is 1 the same as 5?
By definition of a postulate, we don't have to explain.
Agreed.
Anything.
Right? But why this is the one that I would say most people would say, no, you need to prove this to me, right? So we're going to kind of semi-prove a postulate. So why is this true, Matt? Why is 1 the same as 5? Why is 3 the same as 7? Why is 4 the same as 8? Why is 2 the same as 6?
Because postulate 10 says.
And that is not good enough.
This is us trying to get out of work.
What do we know about H and K?
They're parallel.
Okay, so you think about this. If these two are parallel right here, and I were to move line H down and keep it parallel to K, what's happening to angle 1? Is it getting bigger or smaller, or is it staying the same? It never changes because it's parallel. And that's why we don't prove this one and why we're supposed to accept this one. But I realize this one you might have to need it proven to you. Notice, if any line stays parallel to H, notice that relationship between this angle and this angle. If I were to turn it this way, angle 2, do you see what I'm doing? Angle 2 would be getting bigger or smaller. But if I never change it, angle 2 stays the same no matter where I put this, as long as I make this parallel to H. Yeah.
What about vertical angles?
We'll talk about that here in a second.
Getting ahead of them.
Yep. We okay? Do you have this written in your book of truth? Very popular one to call out and approve. Hey, corresponding angles congruent. But you can only say that if the two lines are parallel. All right, so you guys already named me my corresponding angles, and I know you did pretty good. I mean, I was impressed. Most classes that I teach, when I get to the, hey, you name the thing, the relationship, and then you give me the angles, I usually have a couple people get those wrong. So it turns out if two parallel lines are cut by a transversal, you only need one angle to name all 8. Think about that. If you have this construction right here, if you measure any one of these 8 angles, you can figure out the rest of them just by that one postulate and one other thing. So you need to pay attention. This is tonight's for homework. So I'm going to give you one of the 8 angles. You're going to tell me the other 7. How in the world is that even possible? Okay. So this is what I'm saying. You will get 2 parallel lines cut by a transversal, and they will tell you one of the angles. This is in the way, but it says 140 degrees. It says that angle 1 is 140 degrees. It says angle 1 is 140 degrees, and my claim is you can tell all the rest of them just from one angle. Okay, so maybe a little bit of labeling, right? Angle 1 is right here, right? So let's label. Why is this not clicking? Because I clicked on that. There we go. It's 140 degrees. All right, you ready?
Yeah, sure.
Karis, how big is angle 2? We're thinking. How many people are sure they know the answer right now? Good. All right, Karis, you're going to be with them in 10 seconds. You ready? How big is it? What shape do you see now that I've covered up the rest? How many degrees in a straight line? Therefore, how big is angle 2? And if you can't do the math, just tell me what math I should do. I'll do it for you. 180 minus 140 is 40. So how big is angle 2? Boom, you did it. There's geometry. 2 has got to be 40 degrees. But wait a minute. We know that 2 parallel lines cut by a transversal also has a corresponding angle. What angle corresponds to this one? 5 does. So if this is 140, how big is angle 5? Angle 5 has got to be 140 as well too. And that is how we're going to get all of the angles along with vertical angles. All right, I won't do these in order. Paris said angle 2 was how big? 40, right? So if that's 40, how big is 6? If this is 140, how big is angle 3? Well, you could do the magic, hey, what shape does it make? Straight line. Or you could say that these two angles are the vertical, so therefore angle 3 is 40. And what corresponds to angle 3? Angle 7. Or you could say that it's vertical to this one, and then vertical, vertical, and you're done. Did I do that too quick? How many angles did we need to figure out all 8? Just one. Just one. Just one. My geometry teacher, although she was great, she never pointed this out, but I figured this out quickly. How many different numbers do you see up here? Dose, right? Turns out in this construction, there will only ever be 2 numbers. Sometimes only 1 number. We'll talk about that at the end of class. There's only ever 2 or 1 number. So if you figure out what the 2 are, you got them all. Hey, as soon as I give you the first one, you figure out the second one, you're technically done. Just remember, one is always going to be acute, and one is always going to be obtuse. Unless they're all right angles. And that's the case where there's just one measurement. Okay, that was something that I realized, I don't know, quickly, and I'm not sure why my geometry teacher, because then she gave us like 4 of these to do for homework. I was like, well, this is silly. I mean, I got it figured out immediately, sort of thing. I'm going to give you one, and it's in front of you right now. In front of you right now. So your job is to figure them all out if angle 5 is 60 degrees. I'll give you a 20-second head start, and then I'll talk you through it. See if you can do the whole thing by yourself. If not, are you pulling out a calculator to do this math? Oh my gosh. Luckily for you, I said you can use a calculator. I just will certainly make fun of you if it's a simple calculation like this one. If it was 61.376 degrees, I'm with you. Matt, it's 60 degrees.
Yes, it is.
Okay.
So do you know the more?
Yes, I will only shame certain people, and Matt's one of them. Yes. We'll figure it out. Oh, the proof. I bet you're showing me that. You were just missing the last step. Yeah.
All right, I figured it
But
out.
yes, you absolutely got it. Okay, so that's your 20-second head start. So let's see. Angle 5 is right here. It's 60. Well, 1 corresponds with 5. That means 1 is 60. So angle 1 has got to be 60 as well. I'm just going to do them in order. Let's see. 2 is right next to 1, forms a straight line. Therefore, they're supplementary. I'll do math. I like that. Math. 120 minus 60 is?
Sorry, 180.
180. I even messed up math, right? 180 minus 60?
It's 120.
It's 120. You did that without a calculator. Good job. Angle 3 is vertical to 2, so therefore 3 is, and I'm just going to say, I'll call this Miss Shanklin math right here, my geometry teacher. Once you have the 2 angles, you're done. You just got to figure out which one is obtuse and which one is acute. Well, 3 is obtuse, therefore it's got to be the large one. Or you can see it's vertical, so it's got to be 120. 4 is next to it. 4 is acute. It must be the small one. Or you could say if 3 is 120, 180 minus 120 is 60.
You could say 1 vertical.
You could. Well, let's see, what's vertical to 5?
80.
And if 5 is 60, then 8's got to be.
60.
And then 6 is corresponding to 2, and 2 is 120. Therefore, 6 has got to be 120. And then we got your vertical, right? So 6 is vertical to 7, so it's 120. 5 is vertical to 8, so therefore 8 is 60. Did you guys beat me?
I beat you. You're really confident.
Danny? Yes? No? So easy or hard concept? So when the picture looks like this, no one gets it wrong. The issue is they're going to draw some extra lines. They're going to draw something like that. And then you're kind of like oh, there's too many lines there. So one technique in geometry is to erase the line that's giving you problem. If this red line that I just drew right there, and usually it's something like this, and they'll say these two lines are parallel as well too. I call this a tic-tac-toe one right here. But it just gets really messy. So a technique is to just draw the ones that you need. Ignore the other ones. So you'll see it when you get to homework, and some of the pictures are just not as friendly as the one that I have depicted right here. We good? All right, I only give you one example. Usually kids can do this one pretty good. So I said we're going to do 2 proofs, and the first one I said that you should be able to do all by yourself. No, I'm not going to say do the proof. I will help you, but I'm not going to really force feed you like I've done in the past. So this is the first proof, and the one that I said that you should be able to do all by yourself. Maybe a little bit of encouragement from me. You ready? All right, Karis, what's the first statement? The given. So I simply rewrite it and write given. Danny, what's the last statement? The last statement is always, never changes. The last statement in any proof is always, Danny, the proof. Now, I'm going to show you how much work this one involves. Notice there's not much space here. This is how much work this one involves. Now, would I, if I were really doing the proof by myself, put it right here? No, I'd put it right smack dab at the bottom, because you don't know how many steps it will take. I'm not going to give you any proofs this year that don't, I mean, the space I give you is how much space you need. Now, because I'm doing PowerPoint, you can see how many steps there must be. All right, right now I've only told you one technique to solve a proof, which is basically, I call it vomiting on the page. And by that, I just simply mean, if you don't look at it and say, oh, I know how to prove that one immediately, then you look at the picture and you say anything that's true about it. Now, we're probably not going to say, oh, look at the angles. This one is cute as this one is obtuse, something like that. But we're going to look at the shape and we're going to say anything that we can about it. Now, I don't know if your proof will look like mine, so I'm just going to roll with the punches and we'll write whatever you say. Wes, you're up first. Look at the picture and tell me anything that you can say. Why?
Because they're, let's see, when we just did it.
Corresponding angles are congruent. So that wasn't my first statement, but we'll make that our first statement. Does everybody see that 3 and 2 are corresponding? Why? 2 parallel lines cut by a transversal, 3 and 2 are corresponding. So I'm going to say angle 1 is congruent to, angle 3 is congruent to angle 2. Why? And this is the abbreviation, core, period, angles, congruent. Okay? That's a good statement. Do I know it's going to get me to the answer? I don't. But I know it's true. You got another one?
Yeah. 1 is congruent to 3.
Why is 1 congruent to 3? Okay, so we got angle 1 is congruent to angle 3. Why? Why is 1 congruent to 3? Vert, angles, congruent. Once again, I don't know what those postulates or those theorems are. Isn't it 3-2 is the vertical angle one, something like that? Is it 3-1 or 3-2? I have no idea. 2-3, I'm sorry, 2-3. I don't remember. Corresponding angles was postulate 10, right? But no one's going to remember that. Okay, you're on there, somebody. You got the answer for sure? Anybody else? How do we go from this to that? He showed me through. He was missing the last step, so go.
It's a substitution.
Is it a substitution? What's this say? Angle 1 is the same as angle 2. What's this one say? But this says 3 is the same as 2. Well, if 1 is the same as 3 and 3 is the same as 2, then 1 is the same as 2. Now, 2 ways we could say it, substitution or this is your classic transitive. If he's the same as him and him's the same as he, then he is the same as he. That's horrible English, but you get the idea, right? That's your classic transitive. And that's how it's done. I'm going to erase this and now write pretty so the e-learners can see. And I'm just going to say, you guys did the whole darn thing. I just did vertical angles first instead of corresponding. That was good. That was really good. You guys did that whole proof. Oh, by the way, we got to say transitive. Substitution I would accept as well too. And if you remember that first time that I said, hey, what's the difference between substitution and transitive? And I said this, when in doubt, write substitution, right? Substitution can always be written in place of transitive. But if I said, do not sing the Baby Shark song in class, and he sang the Baby Shark song in class.
Ah.
He was being a smart aleck, so I'm being a smarter aleck.
10.
It should be minus 10.
It should be -11.
For singing that song, they should probably go.
I told him I was going to play the Barney song very loud to him over and over during the next test until he cried. All right, hey, do you realize that you just did this proof with no help from me? The only thing I said was just tell me anything that you see on the picture, and as a class, we were able to solve this whole proof. That's pretty good. This is what I would claim as being an easy proof, and these are the kind of proofs that you will see on the test. And I'm not going to ever ask you to redo this proof ever, but when I give you a proof on the test, sometimes I give you two, but always I will give you at least one. If I only give you one, it's going to be an easy proof. If I give you two, there'll be one easy, one kind of medium. I'm never going to give you a proof that you can't do just by looking at the picture and writing down some statements. Now, as we get to more challenging stuff, sometimes you're going to write a statement that you never use. Maybe the fact that 2 and 3 were corresponding is true, but we don't need necessarily use it. That part will be true. But as we start off, trust me when I say I will give you nice, easy proofs to do. So this one I fully expected everyone in here, given, I don't know, 10 minutes, should have been able to do this proof. Well, I'm just saying, you know, some people need more work than others. And I just want you to remember my words of just write any statement that's true about the picture and you'll eventually get to it. All right, write this down. This is theorem 3.2. 3.2 says that alternate and interior angles are congruent. If you have two parallel lines cut by transversal, then alternate interior angles are congruent. For those of you that like short and concise statements, the colored part is no different from the top. I just broke it up into the if then. Yeah. Well, remember, to solve any proof or to do any proof, you may use anything previously that you proved. Yes. But to prove alternate interior, we can't claim that alternate interior angles are congruent. Which one are you talking about? The second one? The second proof, you could use the fact that alternate interior angles are congruent because we just proved it. But the first proof, you can't say, well, they're congruent because they're congruent. Yeah.
So let's say in our homework we're doing 2 or 3 proofs. Can I use one of my proofs to help prove?
As long as you prove one first, and then for the second one, you cite the first one.
I can use my homework to solve
Absolutely.
my homework.
You can use anything we do in class. You can use anything that we previously proved, right? You can use anything that you prove as well. I don't know if that would ever happen, but yes. Yeah.
Are you challenging Zach to go prove something about geometry?
Oh, it absolutely is. It absolutely is. I didn't say that you were literally going to do one without training wheels yet, but I'm saying in class we just did. Okay, we good on this? So you can now say the alternate interior angles are congruent. All right, so that was an easy one. This is a I don't know, easy hard proof. All right, here we go. All right, second proof. So this is one that I think I would probably have to guide you through. Maybe I'm making that up. Let's see. Cadence, first statement. Okay, given. All right, notice that this one has a lot of space. Like I said, this is one probably I'm going to need to give you some help. All right, Amaya, you're on. You're going to look at it. You're just going to tell me anything that's true. Look at the picture. And the obvious things like, oh, K is parallel to N, well, that's in the given, or that 2 is acute or something like that, we're going to leave it. Look at the picture and tell me anything that you can tell me. Got anything? Here's your hint. Look at 4 and 2. There's something you can tell me about 4 and 2. They're adjacent to each other. Further, they're also, I'm going to do the Karras trick. Do they look congruent? What can you tell me about the two angles? What shape do they make together? 4 and 2. Straight line. Boom. How many times will we use that straight line now? 10 times probably. You're going to see this throughout the entire year. It makes a straight line. So if they make a straight line, what can I write? I could write that they're supplementary. There's one statement. I'm going to give you another hint. Okay, great. What does that mean? And by the way, what you just said is fine. We're just going to do a shortcut. Instead of just saying they're supplementary, we're going to make one extra statement. If they're supplementary, what does that mean? That's what I'm going to, now tell me what to write. And you got to tell me the geometric way of writing, they add to 180. So literally, what am I going to write? And it's not that they add to 180. How do we write that they add to 180? Perfect, 100%. And the reason? Okay, two ways you could say it, that the two angles are supplementary. You could also say, somebody else? I would accept that. Anybody else? What? Addition, the book likes that. I don't like that because it doesn't tell me that they add up to 180. It just says that this one plus this one equals the big one. I would still accept that. I would say one more thing. That's basically what Amaya said. Definition of straight line, right? Or definition of a line. All lines are straight. Even though I literally wrote straight line, Miss Shank would mark me off right there for saying straight. She would say that all lines are straight. That's true. Okay, good. So Amaya, you tell me, was that like pulling teeth or was that okay? Kind of see. By the way, anyone else, is there anything else you could say about this picture? Where are you getting that from? They're not, 1 and 4 are not alternate interior.
Oh, wait. 1 and 2.
Oh, 1 and 2. Does everybody see that? 1 and 2 are alternate interior. We just proved that. So we could say,
1 and 2. 1 is angle 1 is
okay, so I could say angle 1 is congruent to angle 2. What? By theorem 3-2, or I'm not going to remember, it's 3-2. I'm going to say alternate interior angles are congruent. Alt-int angles congruency symbol for those that want to do a shortcut. That makes sense? Alt-int angle symbol congruency symbol. So the next step I'm going to have to help you with, or maybe not. You got something?
substitution.
Yeah, but this says measure. This doesn't say measure. So I can't do a straight substitution. I need one step in between. But it is along those lines. I would like to do a substitution, right? But this says measure and this says angle. So this is talking about how big it is. This is saying that they're congruent. We got one little silly step in between.
So could you also say that angle 2 plus angle 1 would equal angle 180?
We don't know that. We just know that they're congruent. In fact, the only time they would be supplementary is if they're equal to 90. All right, this is going to seem like a silly step. You ready? I need to say that their measures are equal, right? I need to say that the measure of angle 1 is equal to the measure of angle 2. And it's because of what Wes said. He wants to do a substitution, right? By the way, what's the reason? Why can I say this? If they're congruent, why can I say that their measurements are equal? The definition of congruent says if two angles are congruent, it means their measurements are equal. So that's the definition of congruent angles. All right, so we got the first step, we got the second step without any prodding from me other than saying, look at the picture. The third step, I had to guide you through that one. You got to be ready for this. This is, I'm thinking ahead of what I need to say for the next step. Seth, do you think you know your next step?
What are angle 1 is supplementary to angle 4. I've not been paying attention.
I know you
So
haven't.
since angle 1 is congruent to 2, then we can substitute 2 in our little addition up there. So angle 1 plus.
So instead of writing angle 2, we can now write in statement number 2. What can we write?
1.
We can say 1 plus 4 equals 180. Why is that important? Why do we want to say 1 plus 4 equals 180?
Because it's the definition of a supplementary angle.
Boom. So this is one of those chess things, right? Good chess players don't do one move. They're thinking 2 or 3 moves ahead. And this is why proofs are hard, right? Once you write the 2 statements that, okay, I've written everything I know, now you got to play some chess, and you got to look to see where you're going. Last step, and kind of figure out. I'm pretty sure that Wes knew what he wanted to do. For the rest of us, this is the skill that makes geometry hard, is being able to look ahead and saying, oh, why do I want to make that statement? Because that's what's going to get me to the very end. We did a substitution right here. So the last step is, how does this turn into this? Because somebody, so that's the definition of supplementary angles. 2 angles that add up to 180, right? So definition of supplementary angles. And we're done. So I call this one an easy hard proof. This is only hard because of this one little silly step right here. I think Wes, if I had not told him, would have immediately jumped to that and then to there, and I would have like taken off 1 point for, hey, you never showed me. You're not really doing a substitution between these two, because one says measure, one says that this thing is congruent to this thing. But this technique right here, we're going to see many, 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 many times this year. We good? All right, so there's your challenging proof right there. All right, this is theorem 3.3. What did we just prove? We proved that same side interior angles are supplementary. Same side interior angles, 4 plus 6 or 3 plus 5. Now, we're not saying that 3 is the same as 4 or 5. That's not true, at least not in this case. But we are saying that if you go to the same side interior, you add the 2 together, you get to 180 each and every time. So let's say we got corresponding angles are congruent. We got alternate interior angles are congruent. This one doesn't say congruent. It says they're supplementary. Same side interior angles are supplementary. We're getting a lot of stuff in our book of truth. A lot of stuff. Once again, people won't remember it's theorem 3.3, but in a proof, you'll simply say same side interior angles are supp. I'm impressed. You guys are doing really good today.
I would be doing a lot better with sugar.
If you had what?
Sugar.
Sugar? Well, the fat in your body gets converted to sugar when you don't have sugar.
My body's not working.
All right, we good? Okay. Theorem 3.4 you have tonight for homework. It's a baby proof. They fill in a blank proof. It says this. Now look at the board. I gotta talk you through this one. It says that if you have 2 parallel lines and the transversal is perpendicular to one line, then it must be perpendicular to the second line. It seems kind of silly, right? If you have 2 parallel lines cut by a transversal, and the transversal is perpendicular to one line, then it's got to be perpendicular to the other. I would call this, to me, this is a corollary, not a theorem, but they call this a theorem. Because this comes directly from corresponding angles. Well, if it's perpendicular to this, then the corresponding angle is right here, then, oh, I'm kind of giving away the proof, aren't I? I better stop talking.
Hey, but yeah, the bad. I feel like they just do.
Well, they're going to force you because it's a fill in the blank proof. For
yeah.
me,
I
right, I could do this in 2 lines. How many lines do they take to do it? Micah?
6.
How many lines? Yeah, I could do this in 2 lines.
No idea.
I would just simply say, this is perpendicular to this. By definition of perpendicular lines, then it's perpendicular to that, and I'm done.
Can we just do that?
No, you got to follow their proof.
Crap.
Because the fifth one is a substitution.
Yeah, they go into a lot of detail. All right, so that's theorem 3-4. That's the last theorem of the day. We're going to look at some other stuff. Two parallel lines are cut by transversal. The transversal is perpendicular to one of the lines. It's got to be perpendicular to the other line. Am I okay to move on? Okay. This is question number 13 tonight for homework. All right, what have we done so far? This is really huge, right? We're going to use every one of these, or maybe not the last one, throughout. What's just happened? If two parallel lines are cut by transversal, what can we now say? Two parallel lines, what can we say? Give me one thing that we can say. What?
The same side interior angle are supplementary.
Same side interior supplementary. What else can we say? Not complementary. What do you got? Alternate interior angles are congruent. What else can we say? One other thing. Third one. What's the third thing we can say? Corresponding angles are congruent. That's what we can say. Those three statements right there. Oh, we're going to have more tomorrow, right? But that's what we can say so far. All right. The fourth one, it's kind of cheesy, but it's there, right? These three we use a lot. This one, I could also say it's corresponding as well, too, and say the same thing. All right. I got to show you this. It's tonight for homework. In math, we are lazy, except we don't say lazy. We say we are efficient. So here's the statement. It's kind of in your book. I'm going to show it to you in picture form. Are you watching? It says that mathematicians are lazy and we don't want to do much work. Here's what it says. I don't want to draw arrows anymore because I'm lazy.
Oh my God.
So in geometry, at this step, we're not going to draw arrows anymore.
What?
Right? So now we're not going to draw arrows. But what we will do is when two lines are parallel, I also don't want to write this because I'm lazy. So I'm going to have a symbol for this. You ready? So I'm not going to draw arrowheads anymore to show lines. I'm going to put the arrowheads on the line, somewhere in the middle-ish, right? Sometimes towards the end. And guess what these red things now mean? They don't mean it's a line.
It's parallel.
It means that these two lines are parallel. Before, after. Hey, this still means line L and N, even though I don't have arrowheads. Even though I probably in pre-algebra took points off of your test if you didn't put arrows on a line. Now we don't put arrows on lines. Why? We're just lazy. The arrows we now reserve to show that two things are parallel. Two rays, two lines, two segments, that sort of thing. Okay?
This little lines that go in.
Not parallel.
If they're not parallel, they don't have these little diamonds on them, or these little triangles on them.
There's not even arrows on these.
And there won't be arrows, right?
How is this more efficient? So then how do you know?
Because I don't have to draw 1, 2, 3, 4 arrows. I don't know, but that's what we do.
So it's a line segment only if you have dots.
Dots on it, right? Or it says line segment. Hey, what's QP?
Something.
What shape is QP?
It's all right.
It's a line. Why? Because it doesn't have arrowheads on the end of it. It's a line. Hey, what's RS? It's a line. What do these two red triangle thing mean? That means this line is parallel to this one. Okay, if this one is 90, how big is this one? Up here, I'm supposed to hold you for 2 more minutes. If this is 90, how big is this? Okay, why? Not because two parallel lines are congruent. Why is this one 90? State your source.
The geometry.
I can think of 2 reasons. Sit, Chandler. I can think of 2 reasons why this one is 90. Give me one of them.
Theorem 3-4.
Theorem 3-4 is one of them. It says it's perpendicular once per. What's the other statement I could make? Why is PQR 90? He said 3-4. 3-4 says if it's perpendicular to one, it's perpendicular to the other. There's another one we could state. What's the relationship between these 2 angles?
Adjacent angles are congruent.
Sit.
Corresponding.
They're not corresponding.
They're adjacent,
They're adjacent.
and adjacent angles are.
What do we have? What does the red indicate?
Parallel.
Two parallel lines cut by a transversal. What's the name of these two angles?
Interior adjacent angle.
Better. What's the better definition of what these two are?
Interior angle.
Same
Better.
Same side too.
Same side interior. What did we prove today about same side interior angles? They're supplementary. So either 3, 4 or same side interior angles. That's what you're going to do tonight for homework. One more. All right. Remember what I said? Mess. You got a mess here.
Oh, geez.
How many lines are parallel?
Oh, why is there?
Ah. There are 2 pairs of parallel lines. This one is parallel to this one, and this one is parallel to this one. So why did this one need 2? So you can identify the difference. Okay.
So much easier.
So here we go. Last thing, and then you're done. Hey, this one's 40. How big is Y? Well, how do you know it's 40? Corresponding. If this one is 40, how big is Z? 140. Where are you getting that from? Say it. No, they're not straight.
Forms a straight line.
Turn your head to the right. The right, Matt. 2 parallel lines cut by transversal. What's the relationship?
They're yeah.
Same side interior, they're supplementary. So if this is 40, this one must be, how big is X? How big is X? And be careful.
Okay.
It's 20. It's 20. It's 20.
Where are you getting 20 from?
Where are you getting? Go ahead.
Wait, 140 divided by 2.
I don't know.
Yeah, but how did you know this was 40?
It's 60.
60.
How did you know this was 40? I can think of 2 reasons.
No, it's
Alternate interior or same side interior. This was 140. That means this is 40. Therefore, X 20. Get out of here. See you tomorrow.
Oh, I did my math back.
There you go, e-learners. There's the explanation. That is a explanation. There are others of why X is 20. All right, if you have any questions, send me an email, and I will see you guys tomorrow. Hey, a few of you did not take your geometry test. Take your geometry test before I put a 0 in the grade book.
Don't get a 0.